there are some open. All right.
Cool. So here we are, on the Open Security Summit session on basically looking at how to make our security teams uh, more effective and how to scale, right? And Jacob has some really cool examples that he's going to share with us. He did the presentation yesterday and one of OWASP events, but we're going to just go through it, and me and him are just going to make comments on it. And again, if anybody has comments and asks questions, just send us over. Jacob, maybe a quick introduction from you.
Hey, I'm Jacob. I'm leading the product security teams at Snowflake in Poland. And on top of security engineering, we've recently starting doing ML security engineering. So once we've hired those people, we hired also people who have background in data science, and we simply started doing security with AI. So that's what we'll be talking about today, right?
Cool. Yeah, and I think that's definitely some of the examples we're showing and we'll go in, right? I feel there's so much areas of security that we couldn't scale, right? So much like information that we would create, and then either because the information was in the right format, or we needed engineering, or we needed stuff. So what I really like is this idea that part of our app now has sort of a prompt and a kind of a layer of multiple models, right? That then you have the APIs and you kind of constrain that a bit, but suddenly we don't have to code everything, right? Every analysis that we have to do, like the example we were just showing, we'll go through, like, you have a bunch of threat models. In the past, if I wanted to process them, I had to write code for it. And then if the schema was not correct, if the thing was not in the right format, you then gets more complex. Where now you can use one or several models, especially some models that might be good or train at a certain thing, and then you use that. And it doesn't matter if the original data is a little bit, not 100% in the right schema, you can then start to convert them, right? And that makes a massive difference.
Yeah. And that brings down that security is a data problem, right? We've got a lot of data available, but we're not using it for security, and we should start doing it. And the fact that we don't have it structured was a challenge for a while, but I think now with the existing technology, the problem of unstructured data is becoming um, less important because we can just make the data structured with, for
Yeah.
example, with the
But it's interesting because I was reading this thing from, I think it was McKinsey, who did a big internal, again, bot, and they were saying that the big challenging issue was actually not the bot side; it was the data wasn't effective. Like they had tons of data in PowerPoints, right? So suddenly they had to figure out how to do this, and I think it's also one of the elements that a lot of organizations are realizing, that the problem is not necessarily the AI bit; is the fact that the data is not well structured. The data needs to be cleaned up. The good news is we can use GenAI to clean the data, right?
Yep,
So,
they're right.
but
Um,
like, let's go through your deck, and then let's just comment, because there's a bunch of really cool areas on it, right?
yeah.
So,
All right, so just to explain what I'll be showing, I'll be showing some very simple examples of how we use LLMs for managing our internal AppSec program and getting some more insights from the data that we have. And the last example that I will show is a little bit more complicated, but it definitely brings more value. So quick intro. Um, we do something we call developer-driven security, and it's a security review that starts with a risk assessment. So the engineers for every product feature, they need to answer a few questions. Those questions are custom per team. We don't ask front-end questions, the backend front-end questions, the backend teams, and vice versa. So we've got a lot of questions in our database, like few hundreds of them. So the risk assessment basically defines
but
the
when you
risk.
mean, sorry, when you mean develop a change, right? You mean like a pull request?
It's not per pull request level. It is at an epic level. So basically a product feature,
Okay.
an aggregate of like work done by one engineering team. So let's say 10 people for a quarter.
Yeah, that's really cool, because one of the patterns that a lot of people did before was they would put those items. I know a lot of people did it in Jira, right? There was literally a series of forms or sequence in Jira that you would put. So at least every story had that kind of security thinking, right? What I think about cool about this is that you can now, in a way, think about it, you should be zooming in. There's all to the pull request, even to the change request, right? But we need to automate that bit. So I guess, if this then gets to be customized, right? That will start to scale quite a lot. It also tells you from a security team, right, what areas you should be focusing on, isn't it? Because it gives you early warning, right, on the changes that you don't care and the changes that you care.
Exactly.
Yeah.
Exactly. One thing to add, we actually have a connection between those risk assessments and the epics and the pull requests, because the epic is then decomposed to tasks, and each task has a linked pull request. So we actually can build a blocking merge gate that will not allow to merge code that does not have a corresponding security review.
Are you starting to be able to check if the review and the analysis that was done initially actually match what was done? Because sometimes people go, well, I'm only going to do this bit. And then when you look at the code, it's like, oof, you changed that.
And this is a very non-trivial problem.
I know.
Checking if code corresponds to the design. If we get that, it's very interesting, and applying this retroactively for all previous features would be.
But that's exactly the direction of travel, right? Like, I'm imagining a world where every single pull request, every commit, it has design architectures and it has a match and a diff against the current design. Now, that only sounds massive if you start top down, but if you start to do that in bits, eventually, if you think about it, it's just abstraction layers, right? Like imagine a code function becomes part of a module that becomes part of a package that becomes part of an application. So in a way, at every layer, you're just analyzing that bit. But I love the fact that you can get to a mode where when you make a code changes, you start to understand the blast radius of those changes, right?
Yeah. You brought a very interesting topic, how you can even think about analyzing data and making secure software, right? You can plug in to very left, so shifting very left and plugging into the design, but you can also plug into the code and simply check what are the results, right? The code does not always correspond to the design, so now you can join this and find
but that was the bit that never scaled, right? The reason why, it's funny because when people say we don't do documentation, we don't do this, we don't do diagrams, that's not what they mean. What they mean is we don't want to maintain it, right? Like, it's because change is so fast that in the past, to maintain those diagrams, to maintain that architectural flows was too expensive, right? Because it wouldn't reflect. But if you give it to them, they want it, right? Like, how many times I've done a security review and I would give them an architecture diagram of how it really worked. I'm like, great, this is really cool, right? And they would even use it in their own meetings, right, to explain how the thing worked. So I think that's definitely a direction of travel. And for the first time, we have the ability, right, to really start to understand that and map that, and then get the LLMs to create that from the code, right? And if you think about it, it almost starts to reward code that is actually then easier to graph, code that is easy to document, code that is actually easy to map, versus code that might work but is freaking super complex, right? And it looks like a gigantic blob, right, architecture-wise.
Yeah. Very, very, very much.
Cool.
All right, should we move on? All right.
Yeah. So go back to that one. So basically, so then depend on the change, right? It requires architecture diagram.
So it either is low and the engineers go to productions, they simply ship the feature. If it's medium, they draw a threat model, and if it's high, we also do some provide some consultation or a pen test.
But this is still faith-based security, right? This is them telling you what they think the risk is.
Oh, but we review it. We've got security champions. We've got security engineers reviewing those. So there are two levels of approvals, and we do some retroactive audits. So
that's really cool.
It's quite reviewed. All right. So we ask a lot of questions here. Maybe not a lot, like 10 or 20 per feature, but we have a lot of these different questions in the database.
Are they LLM now driven? Like, do you actually customize the questions?
So we don't do it now. Currently, we have these static questions that are actually owned by these teams. They can change it, of course, with our approval. But we have these questions, and what we struggled with is that the engineers were often asking, "Hey, what do you mean by this question?" Or like,
it's not. You have to be in context, right? So if you think about that, the ideal situation here is that you have the right questions. In a way, you actually can have a wider pool of questions, right? Instead of having 10, you pick 10 because you have to compromise. Probably you want to ask 50, right? But if you have a pool of 50 and then you have a sort of a layer that convert that to the 4 questions, or to almost like 2 first questions, then 4 questions, then 5 questions, like almost like each of those in context, right, of the previous answer and the app that you're talking about. and also in their own language, right? Like, if somebody says, what does this mean? It means that you're really not speaking their language, right?
Yeah, yeah, yeah. No, no. Here, it could be a path going forward. What we don't do it. We have static questions per team. So a team that does a very specific feature in a specific technology
Yeah,
in a product area, they've got a set of 10 or 12, 20 questions that are very specific to their work. So we don't change it very often. Maybe like once per year when they feel these questions are not adequate. Um, does it make sense to automate this with LLMs? Yes, maybe the questions would be of a better quality, but also this process takes just a few minutes. It takes a few minutes for an engineer to fill in the
yeah,
questionnaire, and the only function is to say low, medium, or high risk, and
yeah,
apply some security requirements. So certain questions, they have certain security requirements that apply when the question is answered yes. These are yes or no questions.
yeah, yeah,
So anyways, what I want to show you is that we had a few hundreds of these questions. The engineers were reaching out, hey, it's not clear. So we have a feature within our platform that basically executes LLM on top of SQL. So you can write a kind of a chat prompt, but you can also concatenate your system prompt with data from your database. So
yeah.
so this is just an example to show how it works. Like you run a select query, you select a model, and you select a system prompt. So here is like, what is the meaning of life from the perspective of, and I concatenate it with some data from my database, right? And this one query will result in as many LLM inferences as we have rows in the
Oh, yeah.
table.
And it's
And
important to say that this is also leveraging like this sort of open source,
yeah,
so LLMs like Mistral and Llama 3 that's you're going to show, which it's funny because, the stuff I'm working on, there was a moment where I was like, shit, if I cannot leverage those, it's not going to scale because there's moments where you want to ask lots and lots and lots of these questions and the pricing would not work if you have to hit a commercial model every time. So this
yeah,
also makes a massive difference from a cost point of view, right?
yeah. So this model is smaller, right? It's 8.7B.
Yep.
There are bigger models. There are also smaller models. I will show you some data that what is the difference between those and what kind of benchmarks that we've run. Some of them are very good for security work. So anyways, we've got this set up and we can run a simplest query that you can ever run, which is just selecting Llama 2 model to act as a proofreader, right? And we've run it for 200 questions and the LLM was optimizing for lack of confusion, short questions, very direct ones, and it will rephrase it if needed, right? So we have just basically a proofreader in our company, right? That can proofread our documentation, proofread our questions that we ask, and all of those, right? It's the simplest one that you can think of, but
So here you basically go into your questions that you have on your database, and you're saying, can you just proofread them and improve?
yes,
Well, and by the way, on the topic of making security teams more productive, right? This is the kind of stuff that doesn't is not might be very sexy, but this is what makes a massive difference. This like improves the quality of the outputs, improves the messaging. In a weird way, you could also expand this to start to almost do things in context for different teams, right? Even different languages, different cultures, different, different requirements, right? Teams that are working on mission critical stuff versus teams that operate like a startup, right? But the coolest thing of this is then you start with your baseline and then you can apply it to all these different people. And this is the kind of work that before were just too time consuming and take too long, right? Where now we can really accelerate and in a way make the teams more productive.
yeah, yeah. So then, yeah, I had a discussion about these kind of use cases with quite a lot of people in the company, and they were just dropping use cases. Hey, what if we used not security review risk questions data? What if we used Jira data? And hey,
Yeah,
here it comes because we have Jira data ingested into our database already, so we can now connect all of these dots, right? So we've came up with this idea of a Jira de-escalator.
yeah,
Very, very funny one, a little bit more complicated. So I'll explain you what happens here. We aggregate all comments
yeah,
in a Jira ticket, and we select it from all Jira tickets. So we for every Jira ticket, we'll have the conversation that happened in the comments. We can provide some additional filters just to limit the number of
yeah,
queries that will run. So this will be either that were authored by me or somebody mentioned me in
yeah,
the comment. Okay. And then I ask the LLM to provide me a summary of this in a specific format. So the output should be 5-line response. The first line, how many comments, IDs of their authors, yes or no, was this conversation resolved? What action is needed to resolve? And the fifth one, most interesting for me, is there any action item for me? Start your response with a yes if there is an action item for me, right? And so you imagine a situation where like a lot of people getting pinged and there is a lot of escalations. Your team is not responsive or something. You don't want to get these signals from your peer managers or some directors or the leadership that, hey, your team is not responsive. Hey, here is the tool that you can give to your people as a manager, and they will never get an escalation, right? Because they will have a message before that.
Yeah. Have you looked at outputting this into JSON or like a sort of a more consumable
So
like
so
things?
yeah, formatting this as JSON would be just another LLM query or just
Exactly,
changing
right.
some
Yeah,
prompt. I haven't done this. What we've done is we simply are providing this yes or no. If
yeah,
if the response will start with a yes, it means that you need to follow up and you can create a notification. So you can link this output from this query
yeah, yeah.
with an email or with a Slack message. Hey, somebody's waiting for a response for 2 weeks, right? Something like this. So, anyways, the funniest thing of this query is that we're processing penetration test requests from engineering teams to our team, to the product security team through Jira.
Yeah.
And we observed that some tickets were resolved, even though they were not resolved. So what happened is that the LLM Llama 2B started hallucinating fake conversation that happened in the comments between us and the engineering team, agreeing on the pen test and on its date. And it was very nice conversation. The LLM just made it up that, hey, okay, we can do this pen test tomorrow or something like that. And 1 minute later, because it also provides the date of the comment, 1 minute later, the someone responded, okay, thank you very much, and all of this. So we needed to add some hallucination checks, very simple ones. It's not of course working 100% of the time, but it made the job. Do not hallucinate. Double check that you analyze the conversation and nothing more.
So one of the things that I'm now using is a mode where I use other LLMs to check that, right? So
Yeah,
in a way, the workflow that I'm finding quite powerful, right? Which is almost allows the best models, right, to almost come out of it, right? Can I just quickly share one thing?
sure. Is it
So
called like agents infrastructure, where you have multiple LLMs
yeah,
chained
yeah,
together?
yeah, exactly, right. So the logic here, right, is okay, cool. Can you see the uncharted thing is? Can you see this?
Yeah,
Yeah, so what I was basically showing here is that, so this is like the normal flow, right? You got a question and answer, a question and answer, right? Isolated. So then what a lot of people start doing is that you feed the answer to the next question, right? So you got the thing collected. The thing that I found interesting, this doesn't scale and this gets very expensive. In fact, although you could argue that it's the best possible memory, but this gets very expensive very fast because it literally grows exponential, right? Like, so what a lot of the LLMs do is they basically summarize, right? So you basically have an answer, you summarize, you put the answer here. And one of the things I would like to have more is understanding actually what is really happening. So the ChatGPT and the others, they currently hide this from us, right? We don't actually see, right, the intermediate bit, right, on this, right? So then the next flow is when you can send the same question to multiple ones, LLM1, LLM2, and you get 3 answers. So the way to scale this is when you start to get the third LLM to actually consolidate this, right? Or fourth LLM. So this is where it starts to get interesting. So you see, in your case, imagine your questions going to 3 different LLMs, right? And then you start to see the probability of the 3 hallucinating at the same time, at the same sort of, place become much less, right? Because now you have 3 different, and you can even have one very good, one cheaper, one okay, but like they can correlate this, right? But the really cool workflow is when you take that third, LLM, actually should be LLM4, right? What you then do is you have questions, right, to ask the LLM4 by this LLM5, right? And that's when you basically ask, did the answer match the questions, right? So if you think about it, like you almost, instead of getting, what you were doing in your prompt is you're basically getting the same prompt to check itself, right? Which kind of works okay to a level. I think what I found works much better is when you ask that explicit question, to another LLM. And then you basically say, look, here was my question. Here's the answer that I got. Is the answer relevant? Right. So in your case, would be have that answer made up anything that is not in your original thread. Right. But by then you dramatically reduce the data that you send, because you just send the actual threads, for example, in your case.
Yep. The agent infrastructure of LLMs, that's very powerful.
Exactly, right. And by the way, the other thing I just mentioned here is like I really don't like RAG, right? I'm exploring a lot more with creating graphs, right, of the data, right? Which is kind of that thing we were just talking about of the idea of basically, yeah, if you want to go back sharing, the idea that, instead of, instead of, for example, trying to find RAG text, I'm basically trying to create graphs and smaller versions of the documents and smaller versions of the content. And that's what I start to feed, right?
I've heard an opinion that RAGs are basically a solution for a short context window, and soon we may not have problems with short context windows. So maybe that was temporary.
Well, but for me, the problem I have with RAG is fundamentally it's the black magic of it, right? It's like I have a model that actually has reasoning, and now I'm using embeddings. I actually think there's a lot of value in the vectors, but it might not be exactly right, like where to use it, because at the moment then you have a black magic of, oh, these are the documents that I think are relevant, but that just based on vectors, right, which is based on approximations, right? So
but a very, very good approximation, and
they do, absolutely. So there's there's a lot of value, right? But I'm after deterministic, and that's why I like the graph, because the graph also allows me to tweak it, right? Allows me to improve it with over time, allows me to confirm what nodes are strong, what nodes are not strong. So that's so it's kind of like a RAG, but graph based, right? That's
okay. All right. Interesting approach.
So in your example, right, if you go back to that slide 14, which is fucking cool, right? That's really good, right? The idea would be that you don't ask, this one to check the homework. In fact, you can even ask this to 3 or 4 models, and then eventually you might even find one that is really good at it, right? And that's what you use. But then you get another model, right, to do the final analysis, right?
Yeah. So chain this part with a second model instead of just adding this to this system prompt. Yeah.
But the other thing I think is also super important, I would like to see better support for this, is that I also want to make sure that every step is documented, right? Like it's captured, it's logged, right? So basically everything should almost be version controlled. So you can almost replay back things, right? So you can go back and do a part of your query, go, oh, I want to tweak that bit. I want to tweak that bit. And then it's like a CI pipeline, right? Imagine a CI pipeline for your queries, right? And then you go, oh, not a good result here, like the bug is here, right? So let me fix that bit, and then you run the whole flow. But you're saving, right, the responses every time, kind of, almost like a diff, like JSON files, right? And that also again allows you to do further analysis, but also allow you to debug more when you start to have those interesting gaps, right?
Yeah. So what you mean is feeding the output of the second model back to the first one to rerun it, or
well, what I'm saying is that every step you version control it, so you save it, right?
Okay.
So in that example, like, so I would feed this same query to 3 different models. I would save it. Imagine, visualize a JSON file. I'm actually using SQLite database a lot, but like imagine just JSON files for every one of them. And that output is what I feed the 4th model, which I also save, right? And you kind of go like in and out, right? So it's almost at any moment in time, you can always go back and going, 3 is good. I want 4. No, 2. I want 2 here. So in a way, you could chain this, right, as much as you wanted, right?
Yeah, got it. Okay. So now I know what you mean. What could be also effective is, what do you do with information, the output from the LLM number 2 that checks for hallucination? Because you can either say, hey, there was hallucination, ignore this record, or you can pass it back to LLM 1 and correct this, right? Do not hallucinate about something or add something like this, right?
Yeah, and to be honest, that's quite interesting, because I also found that, sometimes when you can zoom in the prompt, say focus on this part, focus on that part, you get better results, right? So you could have a mode where your prompt gets more and more specific or more complex, depending on how many loops of hallucination, right, you have to go through. Yeah, that's quite interesting.
So the output is was the conversation resolved? It answers yes. If it was not resolved, it will answer no, and you can flag certain tickets and you can make some action, right? So I'll quickly
That was the bit I was saying, that because you didn't put that in a JSON file, now you can't really parse it. But if
yeah.
that was already sort of extracted, because you got yes, and then the action, and then the ID, and the number of comments, etc. If you can output that as an API, then you can do other analysis, right, on top of
Yep.
this.
Yeah, I see this more of like an integration with an email. So if the column will start from a no, there will be an email notification. Hey,
Yeah.
there is unresolved
Mm-hmm.
ticket or something like that.
Mm-hmm.
All right. So this one is simply showing, not searching through tickets with text or regular expression, but with intention. I like the name intentional search.
Yeah.
So we want to, so again, this is searching through Jira ticket descriptions this time, and we want the LLM to act as a top class Jira triage analyst.
Yeah.
And it will decide whether tickets need urgent security attention, right? And we provide some criteria what needs security attention. So let's say the engineers are fixing something that has security impact, either internal data or some secrets or exposed somewhere that they shouldn't be, and some of those, right? So you basically want to detect a situation where the engineers already know about something and the security team doesn't know about it yet.
How do
All
you
right.
capture that here? How do you capture when the security team already knows about it?
So this part we don't have, and I'll show you the results and say what we do with it. But so this is running on all of the engineering tickets. So this is
Yeah.
so we could already know about this or not, but I'll tell you what are the results, like statistics of the results, so that you
Yeah.
so that it is
But this is
clear.
pretty awesome, man. This is how you scale, right? This is how the security team goes from we have
Yeah.
no idea
So
what
you
our
are getting
developers are doing, right? To
So we're
really,
getting signals about something that you would normally learn in the
yeah,
kitchen. But hey,
exactly.
how many conversations in the kitchen you can have, right? Only few per
Yeah.
day. So this is continuously generating these signals that you would get from random conversations, right? So we ran this query on 10,000 tickets with multiple models, and with Llama 2, it generated like 2,000 hits that we should know about 2,000 tickets, right? This was not a
Yeah.
but when we ran it with Maxtroll 87B, out of 10,000 tickets, it flagged three as those that require urgent security attention, right? And out of those three, one of them was actually something that you would like to learn more about, right? And it could be something. So how you can use it, right? Let's say the engineers create 10,000 tickets per day. You can run it daily and simply send this three tickets to the security engineers. Hey, check if this requires a follow-up or not. They'll spend 5 minutes and maybe you will learn about something very important.
Yeah. No, it's really awesome. Really cool.
Okay. I've got number four that is super easy. We've got also our paging system data in our database. So this is just a simple query to forecast the on-call effort that we're doing, right? So this could be a kind of a help for a manager to observe trends. How many pages do we have? Is there a trend that goes up? Should we hire more people in that particular function, or should we do something about it? Are we managing the program well, right? So these were pretty simple examples of using LLMs and forecasting functions. What I've mentioned is connecting and basically running an LLM on data from these systems. But what you can do is feed it back, and that's where we discuss the notifications. You can send Slack notifications, Jira notifications, or email notifications, and all of those.
Yeah.
Um,
It is proper chat ops, man. If you remember when we tried to do that in the past, right? This is proper,
yeah,
chat ops. It's really cool.
right. So the next case is a little bit more complicated, and I should give a bit of an explanation. And at one OWASP conference, I gave a presentation on how we do developer-driven security. So the thing that I've mentioned that starts with risk assessment, it has many other items. I just pasted here 3 slides from this one where we have these custom risk assessment templates. We've got a lot of other things. And I finished the presentation with two hidden components that back in what was it, 2023 February, I couldn't show. So basically, this is what we've been working for a year, and now we have it. So for 3 years, we've been running this program where every feature goes through the risk assessment, goes through the threat model. We save the threat model output in a database, in a structured data, a graph, and we save all of the threats as well. There should be
Yeah.
somewhere here.
There you go, in the middle.
We save all of the threats and the security mitigations, right? So we had all of this data, and
How was
and
it? Was it like Markdown, or was it documents, or was it JSON, or
so
YAML?
it is just so the graphs in the database were just connections, name of the entities and connections between those. So UUIDs, basically a relational database, kind of a graph representation of the diagram.
Yeah.
The threads we are saving in gherkins. So we are doing stride with the rapid threat modeling prototyping. And we simply, for 3 years, we've generated these templates. So this is a template for elevation of privilege threat. There is the criteria, there is the threat definition, and we asked the engineers to fill in how they're going to mitigate it for this threat, right? It's by the way public. The Stride and RTMP automation is public, and it's open source materialized threads from the previous director of our group. So what we have is we had this data from diagrams. We were generating some threads. We had all of these threads in our database. And we started building basically a model to generate those threads from the diagrams. So what we want to automate is not the diagram generation part. The engineers know the best what they're building. So they will still draw a diagram. It will take them a few minutes. But we want to automate filling in the gherkin, so generating the mitigation. So we start from the engineer that creates a threat model. So they create a diagram. And then we trained gradient boost machines models, so GBMs, and we trained it on a few hundred threat models, a few thousand of threats that we had in a database that were reviewed by security engineers. We added RTMP rules and Stride and the list of nodes that we had in our database. And GBM models are just a classifier in our case. So what the GBM model does at this stage, it generates a label for a mitigation type category. So we've got a few hundred of these categories, I think 200. There are two of them here, access control and identity management. We can manage thresholds here, so we can manage how many of them get in the gherkin or what is the confidence score to get into the gherkin, but we generate those labels.
Yep.
There are some good public sources where you can get those categories, like common weakness enumeration, some even OWASP, ISO, or MITRE sources where you can get types of attacks or types of mitigation controls.
But you're trying to reduce the scope, right? So basically saying, given this classified to this, and see that's a good example of that graph, right? So you're reducing the scope of the input to like these nodes, and then that's already an edge, right? So you go, given this, like here's my schema, now map to that one, right? Which makes a massive difference, right, in the quality of the next step.
Yep. Yeah. And this, by the way, has a little bit internal context because these nodes here may have already existed in our database and were used to train the GBM. So it has some additional context. But the main magic, let's put it this way, the main value comes from here. So we've got the mitigation label, and we just want to expand this to something that is digestible by the engineers. So something that is text that is actionable, and it is contextualized within our environment.
Yeah.
So we just run an inference against it to expand the mitigation label. So for example, expand access control with, of course, a proper system prompt, but we also add technical details about this particular solution.
Yeah.
The node definitions. So when we have user browser or there is some component there, data store, we have definitions of those that we pass to the system prompt.
So you see that's the graph, right? You kind
Yep.
of not representing it there. You're not actually giving it justice. But for example, even that node definition, that's a graph, right? Because what you
Yep.
say is, from here, I figure out I had these 5 types of node, right? I go here and I grab that information and I feed it. So you start to feed this really nice, very rich graph to the LLM, right?
Yep. Yeah, exactly. Exactly, graph. But I think the biggest value and the thing that makes it contextualize is the
Yeah.
security guidelines. And I think this is
Your
where,
one, right? It's your security guidance in context for, yeah,
yes.
which is
So,
massive.
and this is something that, we as security professionals, we have a lot of strong opinions. We have some principles that guide our consultations for the engineering teams, right? Uh, Human users should use MFA, right? Or machine-to-machine, service-to-service communication should be encrypted with MTLS. All of these, if they're written down, they can support
Yeah.
the security requirement and make it more contextualized. So in this case, the access control and identity management was expanded to using Okta, and of course this is changed for this presentation. It was an OWASP presentation, but the real value of the gherkin also includes some details, links to the documentation that we
Yeah.
have about using Okta at the company, right? So contextualized security requirements, something that you usually get through like minutes or hours of consultations with the security engineers.
But you can see that this can even start to go all the way to the code, right? This can even be like the foundation of a code change, foundation of, this code requirement is because of this, because of that. Like, so now you start to have this really great connection, right? All the way. And also, I think it's interesting to look at when you find things, either via pen test or reality or as part of this, and you're going, hold on, how come we didn't see that coming, right? Because in a way, you can then start to find gaps in your process by looking at reality, right? And looking and saying, okay, we should have known about this, right? In that particular code change.
Yep. Yeah. So these security guidelines is something that I'm heavily invested in right now
Yeah.
because I think those principles, those strong opinions, those security guidelines, not necessarily policies. Policies you can take from compliance norms, but strong opinions about security. Once you write it down, you can use it in many other cases, right? You can have design docs being commented by an LLM with the knowledge about some security principles that you have in your company, right?
Yeah. And you can make them accountable, right? Like I sometimes find that in security, we sometimes are not held accountable to some of the stuff that we say, right? Like the beauty of starting to have this is people can then challenge me going, dude, that doesn't make any sense. Why you give me this? So you get to learn, right? And also you start to provide more in context. So you can start to take into account that, let's say, the security requirements for a mission critical piece of infrastructure is very different from security requirements from something that's not that relevant, is an internal app, barely used, is not connected to the outside world, right? So you could also start to have context into, and even the execution environment, right? But all that stuff, in fact, you probably don't have there, but it would be interesting to see, to add like context of the environment that the app or the code is going to run on, right? Like, because again, all that stuff makes it, high, medium, low, right? Like the same vulnerability could be super critical or could be like, we don't care, right?
Yeah. Yeah. If an automated solution was to maybe not replace, but support security engineers in providing the best list of security requirements for a given project, what do they use to generate those lists manually, right? They use, of course, their knowledge and expertise
Yeah.
that they've gathered for all of their careers, but they're using context about the company and
Yeah.
context about the security attacks, and that's it, right? If you provide this to a system that may be a little bit, well, currently it is just generating the next proper word in a sentence, but it actually can do some reasoning there.
Yeah.
Okay, so I'll just quickly finish with maybe a question and a brainstorm discussion. So this is a very simplified SDLC process where the engineer takes an idea, they generate some design docs, they decompose it to tasks, they deliver code, and they make it to the deployment. We automated only part of it, where if you have a diagram, you can generate threats and you can generate security requirements. Yet, right? Someone still needs to implement them into the code to make it a secure solution. So there are some trivial problems like identifying vulnerable libraries in code, right? There are software composition analysis tools that do very good job at telling you which versions are vulnerable. There are some non-trivial open problems even in the data science world where drawing a diagram from a doc is not that easy as you would think.
Yeah.
But how many other connections in an SDLC process that has definitely more items than just those few? How many of them can you automate, right? So which data should you use to make a secure solution out of the SDLC process?
Yeah. So one of the things that I feel that we need to get into, even especially on the other one, the slide 39, is the idea that our code will become more and more describable and will become more and more documented. I think it's interesting that the security can help to drive that, because in a weird way, I think the developer world lost that battle a little bit, and they almost allowed that to kind of slip a little bit out of the radar in terms of the documentation doesn't get created, diagrams doesn't get created. But I feel that will improve. And I think what's the interesting thing here is that intersection where you go, look, we actually want, the same way that we think a good project should have a CI pipeline, or needs to have a CI pipeline, we should go to a mode where a good project should have up-to-date documentation, up-to-date diagrams, up-to-date relationships between the functions. And it's not just the SBOM. The SBOM, should be creating all the time. It should be maintained all the time, right? It's almost like you want the SBOM in context, right? Like, I don't care if this particular API has a crazy vulnerability. If nobody calls it, who cares, right? Like, you could have a crazy toxic function here, but nobody uses it, right? So it doesn't matter, right? But I think we need to start aligning in security with development, because the power of that is that the developer would then do the heavy lifting for us. If you think about it, you are still trying to figure out, and we are as an industry, how to socially engineer the developers to give us what we need. The ideal is like, it's like the CI pipelines, right? Think about it. In the past, I was involved in projects where we built CI pipelines for developer teams because it was very efficient. Now, I think most teams have a good pipeline, so you don't need to build one. You have places where you can hook your security activities, right? So I think the power here is that we want to start using the same techniques, but to help the developers to actually spend more time, or we empower them, or we help them to understand how the app actually works, right? And how it changes over time. And that's something that you can start from scratch, but also you start from the real world, which is lots of apps that are already built, that people build on top of it, right? So you start to understand the implications of it. But especially apps that are legacy that you have to maintain, ironically, that's even more important, because you need to know where to do the fixes, right? So I think there's an intersection here between what we are driving from a security to something that the development engineering wants, but still don't have a lot of time allocated to it. But we can drive it because we needed to do our jobs, ironically, right? Where you can argue that the developers, as long as the thing works, the business can put pressure to just go with it, right?
Yep. You've mentioned a very interesting thing about legacy applications. So when you look on this, right, if you have automated going from diagrams to threats to security requirements, maybe you can go further into implementing those security requirements, but that's a different discussion, right? If you provide a way to draw a diagram from doc or from code, actually, from
But you need
code.
to go from code. See, the other problem here is that a diagram from doc is faith-based, right? It's like you think this is how it works, right? Diagram from code is reality.
Yeah. So if you generate diagrams from code, you can retroactively run automated threat modeling for all of the existing code and generate security requirements, or even go further. So this could get much more powerful.
Yeah, but also take into account that what I also noticed that happens in a lot of organizations, that you have an app that, because it's used quite limited, it's okay, right? It might have a bunch of problems, might have limitations. The problem is when the app becomes successful, the model becomes successful, it goes very fast from non-critical to mission critical. And
Yep.
in a way, and sometimes it's not possible to understand what it means because it kind of works, right? But even sometimes the business doesn't have a full visibility to understand, hold on, what you see might work, but that works in that little environment, right? Like if you want to work it here, that is very different. But sometimes technology gives you this false sense of confidence. Go, oh, it works there, it will work here, right? But security could be very, very different. So again, I like what you're just describing, where you can have these models and these analysis, which they are okay as long as the environment hasn't changed. So then you can say, look, my environment has changed, or your threat has changed. You suddenly go, well, I didn't consider this to be a threat. Now I consider, hold on, which ones of my analysis are now weaponized or problematic, right? So again, if you leave those things behind, you can now ask those really cool questions.
And this brings an interesting insight that if you want to rerun this analysis with the new threat surface, we've changed assumptions. You
Yeah.
need to have those assumptions first.
Yeah.
So some assumptions about the existing environment and existing threat surface. So basically, like my take from this is the more the more you have written down, the more you have saved in a structured way in your database about your environment, the more you can run in the future when these tools get more effective.
Yeah. Yeah. And I think now in the past, I could never see how we could scale this, right? Because every little move forward required more coding, required more APIs, and you wouldn't scale because in reality, this code that you have there is 5 different languages with 20 different frameworks. And even by the time the developers correctly finish with it, it's just a flavor of that framework that has its own specific thing. So I could never see how this could scale. Now I can, because you have these LLMs, especially when you chain the LLMs, right? You have these LLMs it's a one-off cost to do these transformations, right? To do these analysis. And that can be running on the background. If you think about it, even if that process you described here is complex, that's fine. That just runs in the background, right? As long as you get it within a couple of hours or a day, it's okay. So cool. Now this was really good, man. I think there's some really good nuggets here, and I think you showed really good examples of how we can now scale AppSec teams.
Cool. Thanks. Yeah, it was very interesting conversation.
Yeah, cool. I don't think we have questions, so dude, we'll call it there. Let's do a couple more ones, and I'm really keen to share some of the stuff I've been working on. Right.